Hey, what's up everyone? Welcome to the stream. So, I'm going to continue working on what I started last week. So let me just raise this a bit. All right. So last week I started working on writing tests for the debugger stuff I've been working on. I don't have a ton of experience with tests, so I don't know if I'm doing everything the right way, but anyway, this is the way I'm doing it. So yeah. Last week this is basically what I put together. We've got Google test as a dependency. I don't know if we'll see it in here. Anyway, I have debugger tests here, and basically this here depends on the debugger and then the stuff it depends on. And the idea here is to actually spawn a process to launch Docker so that I can do the compilation. So compiling here is actually running a Docker image that I created. So that's the only kind of complication really in all of this. Once, and I mean, it's not the only complication. The whole thing is around that. So I've got this sort of like template which contains a makefile, and I make use of that, and I produce source files in the source directory, and then I launch make, and let's see here. Yeah, so over here. So basically we got this template, we copy it into a temporary build directory. We take the source file that we write here in line, which is the thing I really wanted, was I wanted to be able to write source code here in each test, so that we can, see it and iterate over tests here. And then basically we copy the build template, we create our source file here. We invoke make, which is actually what we're doing here. And then what do we do here? Oh, right. So after building this main.cpp, we grab the main.rst file, which is the listing file that is our input, make sure that it exists, and then we parse it. So we create a debug symbols, we create an RST parser, we parse it, and after that, I can actually start writing my test. So this is sort of like the testing phase here. So I'm going to continue working on this. And yeah, we'll see where this takes me. Take a sip. All right. So first things first, I'm definitely going to want to put a lot of this code into a function because obviously this isn't awesome to have to write this in every test. I'm going to need to be able to compile multiple tests. So let's see how we can do this. One thing too is I was wondering if I should, for each test, create a separate build template, whether I should delete it when I'm done. I think I might want to do that. So let me see here. Yeah, part of the problem is if I have a compile that includes the step where we build this, the deletion for that will have to happen later. Maybe I'll start without deleting it, and then we can iterate over that later. Okay, so I'm thinking something like compile source, I suppose. And what we'll do is we'll take the source like this. Yeah, and the one thing here is that to get back the RST file, we need the build directory. So maybe I should pass that in ultimately. Or I can return it, perhaps. Not sure. Because there's a sort of like implicit understanding that you put source files into the source here, like into the build directory source main.cpp, but the listing file will be directly in the root. And that's sort of like a detail of the way the make file works, which is not amazing. So maybe what I can do, yeah, I'm thinking something like, because I might have more than one source, I don't know. Let's start like this. Say compile source, and it'll return the listing file. Or maybe, yeah, you know what? I'll make it an output. I'll just call it RST file. Change it later. Okay. So let me grab pretty much all of this. Like this. You know what? I think I'm going to make it a return value. I prefer that. And the reason why is I'm thinking probably I'm going to end up supporting multiple source files in that case. Let's see here. So I get some source. Yeah, I'm calling it main for now. If I have multiple, maybe I'll do like, you know, I don't know, A1, A2, A3, I don't know what, we'll see. Main.rst. Okay, that's good. And probably I'm going to have like eventually I'm probably going to have like a fixture that does most of this, because we're going to want symbols and parser as data members and whatnot. But for now, this is fine. So here we parse. And there was another thing that I wanted to do here was to sort of wrap up the sub-process stuff as well, even though probably this is the only place where I'm going to call it. Oh, and I think I forgot to do the sub-process destroy, which is why I wanted to sort of wrap it in a C++ class. But maybe it's all right. Okay. Return 0 on success. Just a second. Sorry about that. Okay. So yeah, so we're going to make sure to destroy the subprocess. Then we're going to compile. I'm just wondering if I want to put parsing into something separate, since we're pretty much always going to be parsing. And I think we're always going to get the main symbol name here. Well, maybe not always. It's because all of this stuff here too. Oh yes, I remember last time I talked about this, about the ordering of variables and not wanting to rely on that, so that I would write a little function to be able to get a variable by name. I probably should do that, like, because even for my debugger, we're going to want to do that. Be able to sort of search through scopes, you know? Yeah. Hey, Mr. ED Makes. I've been binge watching your YouTube channel, but even watching at 1.5x, I'm still back on episode 59, the 3D goggles and encoder disk. How did you get from Vectrex to C++ debugger? Oh man, that's a good question. So basically, Vectrex actually is part of the C++ debugger. The idea there is that there's this tool chain that is based on GCC. Somebody forked it at like GCC 4.3, and they added support for the 6809 CPU, so you can actually compile C or C++ programs for that CPU. And so people have been using this to actually write mainly C programs for the Vectrex. And that's cool, you know. So I added a little bit of stuff to the linker scripts, to like the tool chain, to be able to actually support C++ correctly, because there was stuff missing. But yeah, I wanted to be able to actually do, you know, source level debugging of that C++ code. And there wasn't really any way to do it. The thing is that GCC fork doesn't produce like an ELF with dwarf information, which is normally what you'd need to be able to use GDB. So what it does produce are, like, if you turn on debugging, what it does is it produces these listing files, these files with an RST extension, and I can actually show you that here. So like, I have an example here. So like, you know, there's some code here. I don't know, where's yeah, here. There's some code here with a main. When you compile this C++ code using that GCC, it produces, among other things, these RST files. Now this one's been deleted, but it's okay. There's a copy here. So this here is a listing file. It actually shows you the assembly that got generated by the compiler, right? So you got all the assembly code. And sprinkled amongst this are these lines that look like this. .stabs or .stab. There's S and D and all that. So these lines here, this is actually the debug information. It's like this really old format. It stands for like symbol tables. And so, because a lot of debug information is basically symbol tables. So this is your debug info, right? And the idea was that this is just like a really old format. This is like pre-dwarf. And old debuggers would actually parse this text and, you know, use this information to help you do source level debugging. So that's what I'm doing. I'm basically parsing these files, building up the debug information for your program, and I'm implementing a protocol for debugging that Microsoft developed, and it's called, here it is, the debug adapter protocol. So it's sort of like this generic debugging protocol that actually quite a few environments support. So it's this thing here. So obviously VS Code supports it, Visual Studio, but you also have Vim and Emacs and a few other editors, IDEs out there that have implemented the sort of like client side. And what you can do is implement the server side. So that's what I'm doing. I'm basically in my emulator implementing the server side of this debug adapter protocol. And so I serve, you know, like the debugger will say, oh, I'd like to debug this source file, and then I'll say like, oh, okay, I know this file, and I'll say, you know, like there's a lot of handshaking back and forth. The debugger will say, I'm at, you know, tell me what line to be at in this source file based on what instruction you're on. And then if you hit, let's say F10 to step, or you click the step button, it'll send that command, and then my emulator, which is now this debug server, will say, oh, you'd like to step, so let me step enough instructions for whatever the current source line is. So that's the kind of thing I need to do to implement the debugger part. So like I can even give you a quick demo here. So like over here, right, we have some code. I'm gonna compile it. So this is compiling using that GCC toolchain. So now it's compiled. Now if I hit F5, this is like set up to invoke Vectrex with like a parameter that tells it to launch as a debugger. In fact, I can even show you that quickly. Here. So this is what you have to tell VS Code. You say Vectrex debugger is like the name, and then you sort of describe it, and you give it the argument. So like it'll launch, in this case it's hard coded there, but it'll launch my program here, which is Vectrex. That's the emulator, but with an argument which is -daps for debug adapter protocol, and then the path to the ROM that is being built right now. Obviously eventually this will be you know, not hard coded, but for now this is, while I'm developing, this is how it works. So anyway, so if I hit F5 to start debugging, it'll launch Vectrex. And when it works, I think, okay, so I think the reason it's not working, I don't even know why. Why is it not working? Maybe I need to build, because I've now been working on the test, so it's possible that I'm missing something here. Let me just compile this. Oh, okay, it's failing to compile this part, but it should have at least built my emulator. Let's see. So hard to read this Ninja output here. Okay, well let me just fix this. Oh yeah, return RST file. Yeah, no problem, man. And I don't blame you for going at 1.5x. I know that these videos are not, you know, edited and formatted for quick consumption. It's just me stumbling through. So I hope that's all right. Why does it want? Ah, right. Maybe I should return our file system path here. That would make more sense. Okay, so let's see if this works. Now if it, oh, there we go. So it's just because my emulator, I think the exe wasn't there. So now it's asking if I want to attach my debugger. This is just for me while I'm developing it. I'll say no. So hopefully everything works. It takes a little while because I'm in debug, so it's parsing stuff. You understand? That's good. So here you go. So you see, like right now, the fact that the debugger is here at main on line 289, that comes from the fact that, hey, local root. Oh, it's 3:30 for you? Holy moly. I guess you're, where are you at? You're in France or something? Or Europe anyway, right? That puts you at what, like 6 hours? Wait, 3:30. Yeah, 6 hours ahead. So something like that, right? Yeah, so you see, like the very fact that we're here means that Vectrex in the debugger, we basically told it, okay, you know, we're going to break at main. Oh, Germany, right? Cool. I'm sorry, maybe I had asked you before. It's hard for me to keep track. So yeah, so basically, you know, we're here, and then we have like the normal debugging controls here. So if I do, let's say, step over here, this will actually send the command to Vectrex. It'll say, okay, you know, where does that put us? Well, that puts us at this next line. So I actually had to execute some number of instructions to get there. Same thing here, like line 291 encompasses a whole bunch of instructions. The instructions to basically construct a node here, so to actually call a constructor and do initialization and then, you know, complete that. And all of that, of course, is part of this information that's contained in the stabs stuff over here. So that's basically what I've been working on. So it's, you know, most of it is working now. We even have, you know, local variable displays here. So I'll step a few times, and you can see here, like I have 3 nodes. N3 has the value 3 in its V. So that's, you know, struct being expanded. It's got a next pointer that's not set. N2, on the other hand, which has value 2, its next pointer is set to N3. So if I expand this, we should see V3, which is the same one over here. N1 should have value 1, and its next is set to N2. So that's 2 here, and its next is set to N3. So you can sort of see where that's going. And if I step out of this, I'm going to fall out of the scope. So all these variables in scope should be gone. And now we get new variables, just N3 and N2. So no longer do we have N1 or F or B. And then over here we do a couple more things. And yeah, I think this actually sets up an infinite, or what do you call it? Like these 2 nodes point to each other. So it's like a circular dependency. So like you can basically expand these now forever, because it's basically over and over like that, see? So, and then after that we come back to here. Those are all out of scope, and we have only A in scope. It shows A with a garbage value in it. I still don't have, I have like this thing on my to-do list to only show values that have been set. So here I'm showing all the values that are in scope. And then as soon as I hit F10, it'll put 0 in it. So this is the debugger, and it works, you know, and there's still a lot of work to do, and there's still a lot of stuff I'm not supporting, but the basics are there. So that's like, if you watch the last, I don't know how many episodes I've been working on this, and now I'm trying to write tests for it because it's getting bigger and bigger, and I'm afraid I'm breaking stuff every time I make changes. So it's time to write tests, but it's not super easy to write tests because most of the tests, as input, I want to write a C++ program or a C program, and I want to compile it, and then I want to test that, you know, after having compiled it and parsed the listing file, that things in the debug info make sense, you know. All right, local root. Well, I'm sad you can't see it live, but I'm happy that you chimed in for a little bit. I'll keep uploading the VODs, so making sure that people can watch them. Modern C++, yeah, I'm trying. I'm gonna have to eventually change my header to C++ 20 because that's gonna come rather soon, I think. So it'll be fun. It'll be fun to upgrade and start trying new things. This is where I basically get to try modern C++. It's this project. Because at work, you know, right now we're using C++ 14. I was actually still on 11 on the project I'm on till fairly recent. So just glad to at least be at 14. But yeah, I've been working in C++ 17 on this project for a long time, and this is where I get to play with the latest. Okay, so yeah, so what I was saying was that I am going to have to do this kind of variable stuff multiple times, I don't want to have to rely on the location. So here I said 4 because that's the 5th variable that's declared. 1, 2, 3, 4, 5. Not great. So I think what I want to do is be able to search by name. And yeah, maybe given a function I can do, or maybe given a scope, I can say look for it in this scope, and maybe I can add an option to say recurse and find it through all scopes. Alternatively, I could do it at the function level. So given a function, just look for a variable. This is probably the easiest thing to do. Things that would be tricky that I won't be able to do easily. Yeah, like, how does that work actually? Yeah, no, for instance, I won't be able to say, you know, going back to that example we were looking at here, we have 2 scopes here, and if I search by name through scopes recursively, let's say for N3, I'm gonna get the first one and not the second one. So that's the kind of thing that, you know, won't be easy for me to validate unless I do it myself, or say like, you know, continue to search or whatever, or I could just forget about that and make my life easier in my tests and make sure to give unique names, and then it should be okay. Because I'm not so much testing at this point that I support that, though I should. Yeah, so many things. I think I'm going to start with some kind of search at the function level. And obviously this is the kind of code I'm going to move into function later, but we can start with it at the tests, in the tests first, and then move it in later. I think that would make some sense. Const share pointer const function. And what is it that I want to find? Given a scope, I want to return a variable. Yeah, okay. So find variable, maybe by name. And let's say I'll give it a name first. Or maybe I'll put the function first. Okay. I have a way, and I think I might have to pass the function's shared pointer now that I think about it. Let me see something. Oh yes, I have this traverse. Okay, I don't need to give the function's shared pointer, so that should be okay. So traverse the scope. Oh yeah, and I wanted to say, no, I think on a function we will definitely traverse. So give that, and then give a callback that accepts. So the traverse takes the child scope here. So the node here, of course, is the shared pointer to scope and the callback itself. And then this calls the callback with just the node itself. All right, so we should receive this. Okay, so this is for each scope. Now, for each scope, we're going to want to look in the vector of variables. I think I have a okay, and the predicate will be, yeah, so it's just a predicate to find if. Is it const variable? I'll just do this. Auto variable. I think that's right. All right, and then so this traversal, now this does the find if, but this will not actually return anything. That's true. Now, it would be useful if the callback could actually return whether or not it should stop. Yeah, that's true. This will just traverse the entire thing. Because so far I've only used this where I want to traverse all, not to actually find something. I'm wondering if I should make a traverse that works differently if the return type is a bool. Well, I think what I'm going to do is I'll do it later. For now, I'm just going to go like this. And does find if actually return bool? Oh, it does. Okay. Returns bool? But it doesn't actually give it to me, does it? So that's kind of useless. Where am I using this? I don't think I'm even using it. Yeah, this is not very useful. This should instead return an actual iterator, not whether it's the contains should do the bool thing, but not this guy. This is pretty much the same thing. Oh, there is a predicate. Okay. This is more like contains if. Yeah. Okay. I'm not really using this anywhere, I think. So let's just see if I can. Okay. So coming back here, if we found it, then result is going to equal to star iter here. And then we're going to keep going, but the only thing I can do for now is as I traverse, if result, I'll just return. So this is not great because it means we'll just keep it recursing through, but I'll put a little to-do here. Make a version of traverse that checks the return value of predicate pred and stops if it's false or something like that. But for now, this should do, and then at the end here, we'll just return result. And I think I'm going to make this like that, just because it is pretty much what we're dealing with everywhere else. Okay, so coming back here, we'll search main function for I. Well, what I called var1 here. Is this good? Oh, should be const function. Okay, so let's see if this works. First, if it builds. Okay. All right, so we got our code here. So that was the compile of the source. Looks like it did what it had to do. We have our RST file path here. That looks good. I'm going to parse it. Good. We're going to get our main function here. And we're going to, I guess I didn't really need to put that in here. We're going to do a find variable by name. And we should now have, yeah, there we go. So everything here should pass. There we go, passed. Nice. Okay, so one thing too, just to like make this a little bit less noisy, let's put here show output. So we'll say over here, because it was useful for debugging purposes, but not really. I don't really need to see this output anymore. So let's say if show output, do this. And compile source. I'll say false. There we go. So nice and quiet. Although I've got the parsing RST file output, but that's, yeah, I should probably get rid of that. But anyway, still more quiet. Okay, good. So now that we have that, let me see here. So yeah, so what we want to check are things like the name of the type, the actual type itself. Now, depending on the type itself, we want to check different things. Now, these are all primitives. We're testing primitives, so that should be always a primitive type. Whether it's signed, what its byte size is, and what its format is. So let's write a little local function to test each one. So we'll call it like test variable. So we'll say name, type name. Then we'll say, okay, we know it's primitive type, so then we'll say bool is signed, size t, byte size. I think byte size, signed t. Yeah. And the format, that's an enumerator. Oh, it's right here. Okay. Actually, this. So we'll say expect equals is signed to is signed, byte size to byte size, and format with format here. Okay, so now we can write our tests for each variable. So f should be a float, and it should, yeah, is signed doesn't really make sense for that guy. If I recall, floats, I don't even remember what they're supposed to be on this platform. Is it 4 bytes? Might be. And primitive type format should be floats. take off some breakpoints here. Okay, so yeah, primitives, so is signed is true. Strangely, format was wrong, huh? Okay, did not expect that. Let's see what's going on there. Oh, I guess float is signed makes sense. It can have negative values, right? But what I did not expect, so let's see, we got our variable here. Yeah, there it is. So name is f, the type here, primitive type. Float is signed as true, byte size is 4. Why is format int? That doesn't look right. See, found a bug already. Not a bug in my test, but a bug in the code, presumably. Why would that be? When I construct a primitive type for float, see, it just said here, if, oh, maybe because I'm looking in the wrong name? No, this is the name of the type. So if name.find float, so floats and doubles should have gotten type format float. Okay, what's the deal with this? All right, so we've got a no name here. So that's probably the problem. What's going on here? Add primitive type, type name, complex long double. Why didn't that make it in here? Ah. Huh, that's an interesting bug. I see the problem right in front of me. It's because I moved the string name into my, so basically when I initialize the base, which is type here, it takes a string name and then it moves the name into name here. And so because I'm doing this to avoid copying strings and heap allocations for that, I'm doing moves everywhere. I end up trying to access a moved from value in the derived class. So that's fascinating, and that's the bug. So technically, what I should be doing here is, I have two options. Either I have to prefix all of these names with this, so that I access the one from my base class, which is a bit annoying, or we can give this like another name, which is a bit also annoying, but safer, I would say. Or of course I could just avoid moving, but then that means we end up with a copy, which is not really necessary. So yeah, I don't really like changing this just because when for the purposes of autocomplete, when you're typing in the IDE, it's nice to see that it says name. As I've done everywhere else here. All right, well, maybe for now I'll just prefix with this. There's not much anyway, it's just these three here. And we'll worry about it later. But see, this is why you gotta add tests. I made this change not that long ago, and I had no idea that I introduced a bug. So probably floats were not even displaying correctly in my debugger, and I didn't even know. You know, we can even try it. So you see how float is displaying an integer value? See, I just did F10. This is wrong. This is garbage. So now, if with the fix I put in, if we build everything, it should actually work now. I mean, if you ever needed a reason to see why I need tests for this, this is it right here. Even the most basic thing broke. All right, so now, see, now it actually is displaying correctly as a float, and it shows 1.2, which is what we were expecting. So that's great. So we fixed something. Cool. Let's go back to this test here. So yeah, this should be true. So now let's run with these fixes in place. All right, cool. So now the test is passing. So let's go ahead and complete the test. So we're going to have D for double here. I think the double is also 4. We'll find out. It's also presented as a float type. Got a character type char. It is signed. It has 1 byte, and it is an integer format. We've got here UC, which is an unsigned char. 1 byte, also an int. I think we're gonna have a lot of ints here, so we've got I, which is our int. Happens to be 1 byte. I wanted to say here that it might be 2 bytes because it really depends on the compiler flag for that one. So that's signed, and that should be integers. Okay. Now we've got UI, which is an unsigned int. I don't even know if I should really be checking the name of the type. Anyway, so this is not true. This is also 1 byte, still an integer. Don't remember for, let's say here, long unsigned int. I don't remember if it's going to end up being called long unsigned int here. We'll see. And I don't even know how large it ends up being. Actually, I can just take a look. Let's see here. I might be able to just deduce it. Oh, there we go. Long unsigned int. Okay, it looks like it's going to be a 2 byte. Yeah, 2 bytes. Not signed, still an integer format. Okay, let me just stop here and just make sure that this passes. Yeah, that's the only problem with doing a test this way, is because they're all calling a function, I don't know which one is actually failing, right? False, true. Yeah, this is completely unhelpful. How can I make this more helpful? There's something, if I recall, when you're writing loops and stuff, you can give information in Google Test. There's something about, I forget now how to do it, but there's like, sort of like you can name, you can set a variable or something like that, and then if there's a failure, it's gonna print that thing, you know? But I don't know. Let me see here. Oh, that's interesting. You can just stream out like that. Is there another one? I thought there was something else. Predicate assertion for better error messages. Yeah, that might be actually interesting. Use a function that returns an assertion result. You can use the stream operator to messages to the assertion result object. Provide more readable messages. Expect true, write a predicate function that returns assertion result instead of bool. Right. Oh, that's interesting. Yeah, that's useful too. Lots of stuff here. Oh, maybe it's this. Adding traces. If a test subroutine is called from several places when assertion inside it fails, it can be hard to tell which invocation of the subroutine the failure is from. You can alleviate this problem using extra logging or custom failure messages, but that usually clutters up your test. A better solution is to use the scoped trace macro or the scoped trace utility, where message can be anything streamable to pseudo-stream. Scope trace macro will cause the current file name, line number, and the given message to be added in every failure message. Scoped trace accepts explicit file name and, okay, I see. That's more for like, let's see here. Right. So I could use this. That's true. Oh, that's funny. I was actually looking at it. I randomly scroll down and I'm actually at the scoped trace utility. The only thing is that I have to put a scope trace before everything. So something like this, you know? Let's say I did that. Not sure if this is the best approach, but let's see what it gives us. So Google test trace. So CDF, error expected quality of these values. So I guess it means that CDF, so it saw F first. So I guess we're at C then. No. Oh, it's because they're not scoped. Right, yeah, hence the name. For sure, okay. So like basically if I scope these, that would actually be useful. Probably what I will do is I'll put this all into a little table and then I'll iterate over the table. And then actually that will be easier. Okay, now we'll try. There we go. So C is failing for the format. Right, okay. Because sure, I forgot there's actually a character formatting so it can show the ASCII value for it. All right, and then the other one that failed was for UC, where apparently I put is signed true. Oh, I did. So there you go. Okay, great. And now we are looking at UC again, and this is the format. All right, so it should be char as well. All right, good. So now we can continue. Let me show the code up here. So after that one, we have just a few more. LLUI, which is long unsigned int. So that's a 4-byte value, also of int type. We've got long int. Long int. So this is the signed version of that same guy, and that's it. So let's see. Perfect. So now the next part is, do I want to put this in a little table? Maybe I should. Okay, let's see what it would look like. So the only thing I don't like about that is all of a sudden my table becomes, well, I guess I could pass the table into test variable. Actually, if I have a table, I don't really need a function in that point at that point. So maybe that's better. I don't know. Let me see what that would look like. So it would be something like test params. Grab all this. So now the idea would be to actually like make an array, and this, I guess this sort of approaches more kind of like test suites. We would have a test and we would give it a table of values, and this is pretty much what we would expect. So like, for example, I would take this here like that. Okay, so then we've got this compact little table here, and we would just basically iterate over it. Oh, just 1 second. All right. Okay, so yeah, so I was saying is, like, then the idea would be, like, let's say we keep the function, and I probably won't, but if I were to keep it, then we would be able to do, say, scoped trace p.name, let's say, and then just call this function here. And of course, now we'd pass all of the parameters. But at this point, you know, what's the use of having this function? Byte size and then p.format. So now this whole thing would be gone, and it would look like this, right? Let's see if this actually builds. Now, of course, it should pass. So we'll force it to fail on one of them just to see what it would look like. But let's say now we put true here. All right, so we get the failure. And the trace does show us UI. So that's the one I modified, indeed. So yeah. I actually wonder if I was to put just P here, what would it actually show? I guess it doesn't know. I'd have to write a printer for test params. Yeah, exactly. So yeah, this is the bit that we saw here. You can write your own printers for types, and then I can actually do that. Teach Google Test how to print your values. If you write just an OStream operator for your type, it's actually kind of a neat idea. I mean, I don't know if I should do it there, but basically, if I were to write, you know, one of these, like that, then I can tell it how to write this type out. You know what I mean? I could be like, you know, name is name, type is type. They actually do the end? They don't. Let's say I just did this. Would this work? Hold on. Type name. Friend, was it? A friend function of a local class must have been previously declared. Oh, yeah. Doesn't really like this because it's a local class. Friend function cannot be defined within. Wait, I don't need this to be a friend function. Just need to be a regular function. And in fact, since it's a member function, I can just do this. Right? No? Maybe? Still not happy? Oh, I guess it did not find it. So it did not like it. Oh, because it needs to be on the right side, is that why? I don't remember how this works. Yeah, that's right. That's why it needs to be this way. Because right now the way I did it is it's on the left side. If like test param is on the left side of the extraction operator. Anyway, it doesn't matter. I don't care. I'm not going to do it. So yeah, so coming back to this, there's almost really no point to having a function. So what I could do is take all this and just put it here. Like that. And then this goes. Nope. Why is it doing that? All right, good. So I like that better. We'll delete this. Delete our local function. So like I said, I think there's something, if I remember, in Google Test that actually allows you to write parameterized test like this. You basically write your test suite or test underscore p, I think it is, and then it will accept a param struct, and then on the outside you can build out an array with all the parameters, and then just tell Google Test here's a list of values, and I think in that case it even does a better job of giving you exactly which line it's sent because it's part of a macro, so it's aware of the fact that you're parameterizing your test. So that's probably the right way to do this, but I'll keep it like this for now. I just wanted to see if there were any types I should be checking for that I missed. I think I got all of them. I know there are alias types here. I probably should be checking those as well now that I think about it. Because these, I've been checking the like types that are not aliased. But see, like here, for example, let me just go through this. I got these ones, yes. So signed, let's try signed. So what would signed be, right? So these are like alias types. So, oh, and I guess I would have to add signed variable. So signed, yeah, I'm gonna start running out of names pretty fast here. So S. This should be a 1 byte. So this should be the same as int. Like I won't show up as signed because we can see it's a T7 and T7 is integer. So I really should be taking everything from the int line here. Okay, so let's see if that works. This is a little bit slow. A big part of that is because I'm doing this in Debug. It's going to go a lot faster if I was to switch to release. I'm actually curious about that. Let me just see if it works in release here. RST parser will be faster. I don't know if the rest would make a big difference, but I know the RST parser would be faster. Let me just see if it's even worth running this in release. So obviously it's gonna have to build things. I'm gonna have to upgrade my computer soon. It's very much starting to show its age. Pretty much every time I build, I'm at 100% CPU usage now. All right, well, that was about 2 seconds. Whereas in Debug, it looked like it took about 4 to 5 seconds. Oh no, see that was much faster the second time around. Let's see again. Like under a second. Yeah, okay, so under a second. If I go back to my debug version, x64 debug, okay, about 3 seconds. So really not a huge deal, at least not for one test. Obviously it'll add up when I have more than one, but yeah, nothing too bad. Okay, so we'll just stay in debug because it is useful for me for now. And let's keep going with our alias types. I don't think I'm gonna bother with these ones. I don't think I even support the complex types yet. So yeah. I'm gonna forget about that. Unsigned long is an alias for T9, which is long unsigned int. I'm gonna need to add that to my code here. I don't even know why I'm bothering to initialize the values. The idea behind this test was for me to like put maximum values. At this point, not super important. So maybe I should even just remove that as part of this test. And like that would become more part of a test where I can actually run the debugger or test the debugger itself. I'm not even sure how to do that. I have to think about it. Okay, so let's say this one. So T9 is my long unsigned int. Okay, good. Long unsigned. That one's a T8, which is my long unsigned int. Whoops. Let's keep going. We've got short int. Wait, short int is its own type. So did I miss short int? I guess I did. This defines T14. All right, so this is not an alias. I just don't have it. So let's add a short int somewhere. Looks like it basically behaves as a 1 byte signed char. So si like this, and we're going to put a short unsigned int. Let's add these two guys here. After LLI, so short int will be very close to a signed int, so just a regular integer. I call this short int. And short unsigned int is basically the false version of this. Yeah. Oh, okay. Let's see if this still passes. All right, so I failed for LLU, unknown. Oh, what's this? Unknown file error. So I did not like this here. What does that even mean? Usually when I got these SEH exceptions, it's because I ran out of stack space, but oh, var empty. Oh, look at that. I guess I should expect first that the var is found. So I'm looking for LLU. Did I not add LLU in here? Oh, it's there. Oh, maybe there's a bug there in my code. Long unsigned int LLU. Let's try this. Expect I don't know what to use here, but I guess var how do I test pointers? Google test valid pointer. That's normally what I do. Expect, yeah, it does not equal. Can I just do this? Builds. So now it should actually fail because it didn't find the variable. Or not. Actual false, expected true. Okay. Why does it do a read access violation though? Oh, because I'm doing expect and it continues going. I guess expect is not the right thing then. This is assert true. I think that's the difference. Assert will not continue. I guess I should do that same thing here. Okay, so yeah, Google trace was LLU. So now we know. So we know that we're not finding LLU in any of the scopes, despite the fact that it's right there. Very interesting. I'm going to try and put it in here, see what it looks like. Do I have a variable called, whoops. There we go. A variable called LLU. It's there. Type number 8, so T8. Long unsigned int. Long unsigned int. So unless I didn't parse this properly, I wrote long unsigned, which is T8. So let's see. Let's just see what happens. Okay. Oh, it's there. Long unsigned int. So it does see the type alias correctly. Gets a value. Oh, wait a minute. I think I see the problem. Yeah, there we go. I wonder if people watching this are going to realize my mistake like 5 minutes ago. But yeah, there we go. Just a little typo Should work now. There we go. So let's keep it going. That's the whole point of this. So next we've done long unsigned int. Well, actually, no, we did long unsigned. So where are we? Here. So now we got, yeah, so I did short int, short unsigned int. Unsigned short is an alias to T15. So this is another alias type. We got unsigned short, yeah. US, there's no US anywhere. Nope. So same thing as short unsigned int. So signed char looks like it's a new type. Yeah. So this does not define. So we'll go here, signed char SC. So that should be. So that's different from char. Isn't that strange? It defines that it's a separate type. Yeah, I guess because char is sort of special. All right. Anyway. Signed char, and let me see unsigned char. So I'll do the two at the same time. No, wait a minute. I thought I did unsigned char already. Yeah, up here. So let's move signed char up here. There we go. So after unsigned char, we'll look for signed char. Or maybe I should move it here because it's closer to char. And I had an unsigned char. Which I've done already. I've got float, I've got double. I don't have long double, which is actually a new type. Okay, so long double, put it right after double. Should be the same as double. Now I've got void. I don't think I parse void actually. It's not really a type. Well, that's not quite true. Because if you do void star, that will be a type. So I do still need to support void. Right now I don't support it for sure. If I try to detect it. On its own, I can't really write a void thing, so this would definitely have to be a pointer thing. I suspect if I write void star, I'll get a type that is a pointer of T2. So we'll have to do that eventually. bool we don't have. So let's add a bool. Now bool, I know this is kind of a weird one. It ends up being an enumerator, so that's not really a primitive type. So that's what we're gonna, okay, I'm gonna wait for bool. It's not really a primitive type, which means it won't fit in my table. In fact, I think we're done. There's also vtable pointer type, but that's gonna wait. So yeah, I think we've pretty much covered all the built-in types except for the complex ones. But yeah. Okay, pretty good. All right, so this is good. This is a very nice first test. Let me see what it's going to take for me to actually get this committed. So I've got this sub-process sub-module that I've added. So that's good. I do want to add that. Yeah, the CMake. So if build tests, we find gtest. And then we add external sub-process, we add tests, debugger tests. So that looks good. Maybe I should do this in two parts. So we'll do sub-process as one, just adding the sub-process sub-module as one commit. Add sub-process sub-module. Add the it's single header, right? Will be used to launch compilations for tests. Okay, so we got this. And this find if was totally a bust, actually. I ended up using it for no real good reason. I think I'm going to actually revert this. Probably going to rename it later. And I'm going to just change my code not to use that find if. Because really, at this point, I'm not saving anything. Rather just use a standard find if. This is actually a bug fix, so we will put that in as a bug fix. Let's do that. Fix, what we're going to say here. In fact, this would have fixed both float and char. So fix float and char. Char value types being displayed as ints in debugger. was wondering if I needed the gtest main. Oh, yes, I do need it. It's the gmock I don't need here. Yeah. Get rid of that. Okay, so add debugger tests. I won't even say that because it's actually on by default. Add debugger tests target, and I'll just say that I don't know. Debugger tests target. Test primitive. And I'm calling it stabs parser. But really it's doing more than that, right? Because it's parsing it and populating the debug info. But I suppose that is part of the stabs parser itself. This is how I know that the stabs parser worked. So yeah, I guess it makes sense. Okay, so this is great. I feel like we have a pretty good start to this test harness. Should be pretty good to keep going with this. Obviously we have a lot more stuff to test, and I think the way I'm going to go about that is by a little bit of it is going to be looking at a lot of this commented out code, because obviously I wrote all this slowly as I was developing the debugger. I didn't delete anything for the most part because I kept thinking, oh, it's useful to run these old tests, but really, not manually. Like I should really be putting them into proper tests. So like some of these I won't be able to test because I'm as part of the stabs parser, and I'm going to have to come up with a way. I'm not even sure. Like, I guess what I'm going to need to do is come up with a way to interact with my debugger so that I'm emulating the protocol. Maybe, I'm not sure. Yeah, like ideally, I'd have a way to say, you know, start up the debugger and then tell it step, 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 you know, and then maybe this is actually going to force me to do something a bit cleaner in terms of my design, because right now everything is actually in one place, but ideally I would want to say, like, you know, run, I've got a debugger now, and I know I'm at main, and I want to step once, which would put me here, step again, and then I want to be able to actually get back the value of f and read it and see that it says 1, for example. And in order to do that, right now it's not going to be possible, just in the way I wrote my DAP debugger here. It's like the interface of the debugger does not give me that kind of power, because it's all kind of hidden inside, right? So I've got this whole registration with the session for DAP embedded in the initialization of DAP. And this is where all the handlers are registered. And I think what I'm going to have to do in order to write proper tests here is split this out, I think. I mean, unless there's another approach I can take. I got to think a little bit about this. So that's more like testing the runtime aspect, which is going to be more difficult for sure. But there's still a lot of testing I can do just for, like, you know, parsing the file and getting the debug information that we want, making sure that the debug info has what we need. So another way I can look at this is actually go to the, where is it? What I call debug symbols here, which I want to rename to debug info. I should probably do that soon. Anyway, like when I look at the interface for debug symbols, I want to be able to say, make sure all these functions are doing what I expect. Make sure we're resolving types correctly. So yeah, just four declarations, making sure that after it's finished parsing, that those types are well defined. Yeah, I need to write tests. So we just did primitive types. I'm going to need to do enum types, array types, struct types. So everything we see here, indirect types, which are pointers. So yeah, tests for all of those. Let me quickly write this down so I don't forget. And then, in fact, I'm going to look also at some of the things I fixed and then write tests to make sure I don't break them again. Okay, so tests. So we've got primitive types. So we'll just call this done. And we're going to write enum types. I'm going to put indirect types beforehand. I'm going to put struct types here. So for DAP debugger, I mean, there's going to be a whole bunch of stuff here. I'm just going to write some ideas here. We'll need a way to simulate the debug client. I think that's what it's called. I think we are the server, right? Oh, I guess I don't use that name here. Yeah, so that's it. They call the development tool the host or the client. So yeah, and we are technically the debug adapter. now code is embedded deeply in app debugger. We'll need to split it out and offer an interface for example, step, etc. That one fixed. Yeah, I'm gonna have to go through here. Oh yes, I said undefined types. That's going to be part of the stabs parser. So is that what I called it? It's also part of debug symbols. Yeah, I'm going to also want to test scopes. As expected with the local variables in them. Functions, multiple functions, make sure each is available with name and scopes. Variables, whatever. Unresolved types. I'm going to put that up here, unresolved type. So it's going to be a bit more tricky. That's going to be all right, this is good enough as a starting point. There's definitely a lot of tests to write here. I think I will try, if I have time, to write some of these off stream, because I don't know how interesting it will be for me to keep writing these. Then again, it was kind of interesting to stumble on some bugs, and I'm hoping some of you are learning from watching me do this. But yeah. So I think that's it. I'm gonna stop now for the night. I think it's a good place to stop, and I'll be streaming again in 2 nights from now. So Thursday, same time, around 9 p.m. Eastern. So yeah, thanks again for watching, and I'll see you next time.